Okay. Hi, everyone. Welcome to this Workstream meeting, part of the working group serving. This meeting is being recorded, so please adhere to the CNCF standards and be good with everyone in the meeting. Go ahead, Ashok.
Yeah, let me share my screen. Make it a little bigger so people can see. So you were talking about what we can do. Can you all see the screen?
Yes.
Okay.
Looks good to me.
Yeah, the Zoom interface looks a little different from me, so I wasn't sure if it's actually sharing. Okay. So with benchmarking, we have been talking about like what are some of the gaps. With doing it for auto scaling, do we have a good way to get a baseline benchmark? So I've been looking into some of this recently. So the benchmarking landscape basically looks like this for inference workloads, right? You have these model server benchmarks, like each of the model server has one, VLLM, Triton, TGI, Jetstream. Um, they all do a benchmark at a single model server instance level, and a lot of time they are kind of handcrafted to work well with the specific model server, right? For example, TGI benchmark provides a lot of information around um, how different phases like a prefill versus decode phase works in TGI, but it just doesn't work for other model servers at all. On the other hand, the VLLM script is a little bit more generic, um, but then it is limited in the set of traffic that you can generate and what you can observe. So that's the first class of benchmarks that are available, right? The second one are like things that you can use to benchmark hosted offerings, like LLM perf is one. I think this is from Anyscale, which allows you to like benchmark Vertex, SageMaker, Anthropic, and other hosted offerings out there. So these are kind of meant to be used as a common way to compare these API endpoints and how they look in the leaderboard, sort of, right? And then you have accelerator specific benchmark like MLPerf. This is like a standard benchmark that infrastructure providers like NVIDIA, Intel, and then cloud providers like Google, Amazon, and Microsoft Azure they use to kind of show how performant their hardware is for inference workloads. So this also we found not too suitable for like running on Kubernetes or autoscaling related benchmarks. Um, and the last class is the generic web benchmarks that are available, like Locust, Apache Bench. These allow you to perform like generate HTTP load against any server. They have a lot of features in the sense how much concurrency you can get, and how you can generate spikes in the traffic and stuff like that. So these are the ones we found most useful to benchmark like things running on Kubernetes where you have load balancing, auto scaling, and all of it set up. So we have been using a Locust ourselves. I think Jashin mentioned they're using it in ByteDance too for some of the testing. It does lack some features today. One, you can't control the request rate, which would be important to kind of know how many QPS you're sending to your server and how that affects the number of replicas you have and what performance you are seeing. Things like gRPC support is lacking with some of the model servers support today, and a lot of people might use gRPC as the backend from their business logic to connect to the model server for inference. And Locust also comes with multiple pods that you need to deploy. It has a master and some workers that you need to run based on concurrency. The number of workers will change. So deploying it is something that you need to manage. And the last part is load spikes need to be manually introduced, right? If you want to like kind of see how autoscaling works when more load comes in, how do you trigger scale up and how new replicas get added. So those kind of need to be done manually. So some opportunities for us to improve this so we can use it for Kubernetes, and also can we actually make something available that others can use as well to consistently benchmark and test autoscaling and other Kubernetes related scenarios, right? So essentially we need a benchmarking tool for a few reasons, right? The first one, to measure for a specific model server and accelerator, how does the performance look? We have been discussing with the blueprints and now the model catalogs, providing some pre-baked configuration that we want to publish. So with these configurations, you might say, hey, use this A100 GPU for this specific model, 2 GPUs should suffice. Then how do you validate it, and how do you know how performant it is, right? So for that, we would need to run some benchmark as a validation there for any model catalog that you want to provide. And the second point is like, we might want to know the compute saturation point. We have been discussing this in multiple autoscaling related discussions so far, which would allow us to operate at capacity. And the third one is to like kind of set a baseline for how autoscaling performance looks like, and with scale up and scale down, what metrics we could use, what thresholds we could set. Here also we have been discussing about different model server metrics, how to configure those, and to evaluate performance in a setup like this, right? These are like the needs for why we would need something that works well with Kubernetes, that we can run consistently, even across the other OSS initiatives that will come up within the future. So we have a couple of options here, right? One, we take something like Locust, which is really good at standard web server benchmarking, and then kind of try to address some of the missing pieces. And this doesn't necessarily have to be in Locust. We could like do this like outside of it as an add-on or an extension too. That is one way to go about it. The other one is like, but it does come with, Locust does come with its own set of things. That's been a tool that has been out there for a while. So if we don't want to take in all of the bulk that comes with it, other option is to take something simple like a Python-based benchmarking script that the LLM has, and then like add specific things that we would need for benchmarking on Kubernetes, and then how we make it easy to deploy and run for the specific cases that we have. So we could take either approach here. I'm inclining a little bit towards like using Locust and see how we could make it easier, unless we run into something that's a hard blocker for us. But option 2 isn't too bad either, right? So it would be good to get some feedback around that. And as an extension, one more thing I was looking at is like, can we turn this into like an operator on Kubernetes, where we could essentially have a CRD like this, where you can specify point to your like inference server that is running, and then say, hey, this is the queries per second that I want to send. You could eventually support like diffusion models and other things outside of LLMs too. We could use like popular data set that is there, and then kind of mention how the load and traffic should be, how many prompts you want to spend, you want to send. Do you want to introduce any traffic spikes and all that, right? So you would create custom resource like this, and then the benchmark driver would run it, and then it would either like upload the results to like a S3 or GCS bucket. We could also inline some of the results in the status too. So wanted to check how people feel about the operator idea too, and if it makes sense to have this as part of like the serving work group as a new project that we could then use for all ongoing and future benchmarking needs. Yeah, so that's essentially what I have. It's more currently like an idea and direction that we could take based on how people feel and the feedback. We could do more here. Yeah, any questions, comments?
Can you talk a little bit more about the logic behind having the operator? You mentioned having it run continuously or being able to run on a continuous fashion. But normally when you're benchmarking, when you do this much more intermittently, like before you're going to launch a new service, you wouldn't necessarily want your operator. It's like more of an, as part of the admissions process of launching your service as opposed to something you'd be running on a continuous basis. So I'm just curious how you're thinking about that.
Yeah, so that is something that we're looking for some feedback as well, right? Usually you run it before you qualify like a new accelerator or new model that you're looking at. Maybe you want to know how the Llama 3 model is compared to like Llama 2 in terms of performance that you're planning to switch from. So you run benchmarking once to decide how it looks before starting to use it. But the continuous cases where you might want to kind of monitor how the performance is on an ongoing basis, right? Maybe you're rolling out a slightly newer version of the model, or maybe you're making some changes to your autoscaling setup, right? Maybe you change your HPA metric to something else. You want to see how it is doing instead of waiting for your production workload and then observing it in real time. Technically, this would allow you to generate traffic to a setup that you want to look at and then validate it before rolling it out, right? Yeah, so continuous in the sense it wouldn't be something that is always running, but it also wouldn't be very sporadic that you do only once and not do it again at all. At least that's the current thinking here.
Got it. So you mean more continuous in the sense of like, continuous rollouts of new models as you're changing things or changing your configuration of existing models?
Essentially, right? This could be like a CI/CD step where you're like, hey,
Yeah.
Does the performance look good? Yeah, you kick it off and then qualify your any changes.
Okay.
Yeah, I have two feedbacks. I think the traffic, like the traffic shape part looks great. I think current tools lack of some abilities to generate different shape of the traffic to mark the production traffic, right? And so I think we probably can add more like efforts on the static statistics, and that's another I think important part. Probably put it into the status. So what's the throughput or latencies or TPOTs, TTFTS, and those key metrics looks like. So that could be delivered as a result of the benchmark job. I see this like benchmark concentrate on the client side, the traffic submission. So another problem is we need to figure out what's the hardware under this inference service, like what's the number of the pods, what's the pod spec. So that makes the statics takes more meaningful. Yeah, I think that's the two feedbacks from my side. On the client side, from us, we're actually talking about whether we can generate some like tracing data in future. We check Microsoft's like LLM service tracing data. We only have the timestamp input tokens and output tokens, but that's not that helpful. We think if some companies can like expose some real world production service tracing data, that would be super helpful to do the analyze with the benchmark together. Yeah, that's all my feedback.
Yeah, those are great points. I think one of the reason I put it as a thing we could upload to SVR GCS is that we could have all the different metrics that we need, right? Like you mentioned, we also need identifying data on what pod the request was sent to and stuff like that. So we could have like a detailed report. I can expand on it to kind of include what are the metrics we could collect and things we could add. And the other point around tracing, I think like there is some work in the OpenTelemetry side where someone wanted to add LLM tracing metrics, and I think they have been working with VLLM to add some tracing related stuff too. But yeah, I agree. Like along with benchmark, if we have tracing data too, which showed like where we spend most of our time, pre-fill versus decode phase, queuing and all that, I think that would be good to have as well. I can look more into that too. Yeah, there are no other questions. I'll stop chatting here. Feel free to leave any comments in the talk.
Well, I was going to add one comment and one question, which is kind of broader for this group. So starting with the comment, I was looking at the benchmarking API. I think I would probably say that there's two parts of this API that are bundled together, and at long term, anything that's successful usually has as few like explicit dependencies, but like makes the core problem tractable. And so the two things that are coupled is like, what's your performance plan to go test in the proposed API, and what are you testing? But the number of things that you might want to test actually could be off Kubernetes. Like, so just like one concrete example, I want to contrast self-hosting versus a model endpoint. I would have to jump through some unusual hoops to use this API against a model as a service endpoint, right? Like, I just want to contrast Llama 3 serving that someone else offers and its latency characteristics, its performance, its throughput, versus what I can do locally, because maybe I'm moving off that to self-hosted. Maybe I'm tired of self-hosting and I want to pick the right endpoint, or maybe I have two, like in the gateway thing that diagram I showed yesterday, there's like your self-hosted, but maybe you want to fail over. You need to make sure both of those are going to hit your customers' latency objectives. So I do think that the coupling in the API as it's presented, there's two parts. I think there's a missing section in the doc, which is like, split the part out, which is what are the actual requirements for doing a great operational benchmark for the serving platform user. Move that into its own section. That should not be Kubernetes dependent. That talks about, or it should depend on the concepts that are being modeled, like knowing about individual model servers or knowing about the fact that scale can happen. And then the Kubernetes operator is maybe a next step after that, where you're doing a binding between that API and a target, maybe like, in combo with gateways or like whatever the feature is. But I think the real innovation, like you kind of have like it's like the underpants gnomes. It's like step one, come up with a great operational benchmarking. Step three, integrate with Kubernetes. Step two, question mark. I found myself like, as I was reading it, thinking, if we kind of agree that the current state of tools do not allow you to, as an operator or a service owner, effectively benchmark to generate loads such that you can measure what the approximate golden signals would be for that workload under that load, latency, latency spikes, distribution of latency, then that's the real gap. And kind of like that's the number two, the question mark. Why don't we focus on how can we, like, are there others interested in this besides just Ashok and I? Like Jajin, I think I kind of was getting this from you, but like it's like what we're trying to focus on is someone deploying a production inference workload. Like if you're deploying an HTTP app on Kubernetes today, there's plenty of tools over the last 10 years that have made that easier. Most of them aren't integrated with Kubernetes, but then there's that layer above that has that integration. But the LLM use case is both more specific. It's not well served. It's got these gaps, and that feels like something that not everybody's going to need the exact same pattern, but most people deploying self-hosted inference are going to need that approach to test and verify the endpoint before they roll it out. Does that make sense? How do other people feel about that?
Yeah, I can chime in here from the perspective of AI serving workloads here. I think like the other important aspect of benchmarking isn't just like what's the single, like, I mean, obviously you're doing concurrent requests, but then how is like, some of the things we talked about otherwise are like auto scaling based on KV cache usage and that sort of thing. And then if you're tuning that, what's the sort of like performance look like for batched requests and for concurrency, and how is that addressed? So, having the LLM specific sort of benchmarking but baked in is something that would be useful.
What do you mean by baked in? Do you mean baked into a benchmarking tool, or do you mean baked into Kubernetes?
Benchmarking tool, yeah.
Okay, and that was, the HPA example is great. So Zhezhen described hey, we still can't predict KV cache size accurately. So therefore we move to like the traffic shaping and anticipating it. I should be able to benchmark a before and after and say this improved. I don't know if like you could describe the way that you benchmark today, but effectively in my head, Ashok, what you're describing is how would I write the scenario, show that it's invalid, and then make the fix on the back end and run the same scenario and show that all my operational metrics go up. Feels like a common pattern that for LLM teams and LLM inference servers is going to be more common than it would for HTTP apps, right? Like HTTP apps have a correctness problem. Like, you run EDE tests, you generate load, you verify the requests. But then that step above it is, that's completely left to the user. And honestly, there's not that much latency variation in requests. Like you measure it, you look at your latency and you go. LLMs are different. LLMs have varying load levels. You can accomplish different latency objectives with different amounts of load. Like we're generating all these use cases saying latency is a variable that's you're aiming for, but we don't have a way to measure that effectively in the detail. But the workload itself, like we're not measuring quality here, right? There's, that's somebody else's problem. To operate and run the services, inference service at scale, you need a tool like this. Eduardo?
Actually, before this minute, I just was having a conversation about this, about how to measure, and related to what you mentioned in the document, Ashok, of MLPerf. Like, it would be good, I feel like, if we as a working group kind of like invite the MLPerf community, the ML Commons, because that's the umbrella, the ML Commons community to maybe visit us here and work towards that, right? Because they are already the industry standard, right? Like everyone contributes to ML Commons, like Red Hat, NVIDIA, I don't know if Google. And if we could agree on a benchmarking API, as you put in there, and making use of the MLPerf suite of benchmarks for this conversation, I think we are like halfway there already, because this ML Commons community, they have been building the standard, the way of mostly the numbers, right? Like they are not experts in Kubernetes per se, but they like I attended a couple of ML Commons meetings in the past, and they are like mostly academic people that they are very specialized in which numbers to track, how to measure latency in a way that it provides value when you are reading the number. Right.
So this is a yes, and I agree we should do that. And Ashok had this in his doc, and this is like a personal opinion. I think MLPerf is solving a different problem and isn't serving the user that I care about, which is a platform team running service workloads, which is MLPerf is an objective way for a bunch of vendors to show how awesome their technologies are. I don't care about that operationally because that's a static measurement. So I think there's a mindset difference and a persona. We should bring them in and talk to them, but like maybe like to frame that discussion, the framing I might suggest, or like, let me try out potential framing here is, we have a user, somebody running inference at scale. That user has a business objective, which is about selecting a model for quality and then achieving a reasonable cost that hits their latency objectives. They need to validate all of the elements of their production configuration for the core inference workload such that they can verify, changes don't disrupt production. It's not an EDE test. It's not a It's not a one-off necessarily, although I do think it's not, you know, there's a step from like running it frequently to being continuous. We don't have to take. But the key hypothesis is those users are focused on the golden signals of serving, which includes reliability or, you know, other elements. And we need to be able to say, with that user in mind, how would we, what is MLPerf focused on, and will they serve that user? But we should be able to take like, and I think this is like the part that I think is most accurate is the data sets and how they measure that methodology. We shouldn't necessarily expect every user to be an expert in the deep details of what's novel about LLMs. We're trying to like find those elements that make everybody kind of be able to mostly not worry about it, a specific problem until they do. So like, I think that's like what we're missing is MLPerf is about the vendor hardware and the software stack, but we're talking about the operational stack. And maybe we should like do that invite. But like, I mean,
I totally agree with you. Like I said, I was talking about that before this meeting is because I'm helping with a paper, and reading MLPerf results is frustrating because most companies, and I would say even NVIDIA, the teams that publish their results is very opaque, right? Like, oh, we got these huge numbers, but I'm not going to tell you how I configured my Kubernetes cluster. So it's frustrating to read the MLPerf results, but as I was
like
saying,
TPCH.
they have the experience on running benchmarks, and they already have MLPerf. What I'm saying is like, can we leverage something in such a way that we are halfway there, and we can just add the extra that we need for? I understand where you're going. What I'm saying is like, they already did something. Can we just like build on top of what they have? Is what I'm saying. I know that MLPerf is for showcasing. I know it's, yeah.
Well, it's like TPCH. TPCH is a useful system for comparing the performance and behavior of databases. Unfortunately, because it's a number that people look at when they're making decisions about what to choose, you still have to go and do a benchmark afterwards. We need the benchmark you go to afterwards, and we shouldn't reinvent anything that a TPCH like solution has. Like, our job is not to go measure like our LLMs correctly modeling things, or like, you know, like we don't care whether VLLM is right or wrong about how it's generating. That's VLLM's problem. We do care that when I'm in production, that if I change out the hardware and I see a dramatic change in the golden signal, we know. If you introduce new automation, it screws up. So yeah, John, you had your hand raised. Maybe like Eduardo, like your comment, I think is, could you put that on Ashok's doc, and like we can take that as a like, let's develop the, what do we learn from MLPerf part? Like I kind of asked for that middle section. What's the API for doing a golden signals, take the hardware as a mostly closed box system and measure it? And then that's yours on like, let's learn from MLPerf, John.
Yeah, so I was just gonna kind of rephrase of what we're saying. I think we already had all the same points. I was gonna say MLPerf is for kind of like testing single replica performance, where you're in a constrained environment. We have a set hardware, when you have a set application, and then you kind of run it, get that the performance characteristics of that single replica application, right? So what we're seeing here today with the Ashoka's proposing is that is not just testing a single replica, is testing the entire system. In this system, you can have multiple replicas, you can have failovers, you can have autoscaler, right? And all the other operational aspect of it, right? It's really the end-to-end type of benchmarking, as opposed to kind of MLPerf is about focused on a single replica.
And John, you hit on something that I think is important. There's two variables that MLPerf doesn't consider. Width, how much hardware can I bring, right? And latency. Every result I've seen in MLPerf is extended to extract maximum throughput, or it picks a specific latency profile. I'm aware of hundreds of difference of there's at least 100 combinations or particular latency profiles that matter for LLM workloads today, and I expect there to be even more. And LLM latency is a choice. If MLPerf picks one one instance in one dimension, they've lost both those variables. We need to help people, or I would make the argument we're trying to help people test those variables across all the different holding all the other variables, or these are the two things that you're testing, trying to hold that constant, measure the outcome, and see whether it meets your objective. So like if I have a latency target, how much hardware do I need to hit it? If load changes, does auto scaling react? I don't actually care about the hardware. I care about whether whatever combo of hardware I've chosen hits my output. So it's kind of the reverse test, not testing the hardware, it's testing the outcome. I know we're over time, but if there's anyone else who would like to contribute to this, please comment on the doc. I think we have come up with a couple of items. I'd love to help draft like a user story. Like Ray and Ashok and I, like this is something we care a lot about. John's been involved as well. Like we're trying to get to that. Like, is there a common need that multiple people can all benefit from? And yeah, like whatever standardization. This is just the way that a serving workload operator could start with. Just defining the problem helps.
Sounds like a great topic for next meeting. So thank you, everyone. We're 5 minutes
next meeting
over.
We're talking about model caching though. So next meeting is model caching. It'll be the one after that.
Thank you, everyone, for staying 5 minutes after, and see you in the next one.
Thank you.